drain. It's completely pulverized.
Black holes are produced, we believe, by the collapse of the core of a massive star, something like 25 or 30 times the mass of the Sun or more. When it comes to the end of its lifetime, a massive star burns its core all the way past helium, carbon, nitrogen, oxygen, all the way to iron, which has no more nuclear fuel. And when that iron core builds up to a certain mass, there comes a point where it can no longer support itself, and the core will collapse all the way to a black hole, producing at the same time a supernova.
The supernova sends out explosive amounts of energy, so anything in its vicinity will get obliterated. Then the remnants of the explosion fall into a newly formed black hole. And it seems the key to the black hole's allure is gravity.
Gravity will pull things around, just like the sun's gravity pulls the planets around. In fact, stars will happily orbit the black hole for most of its life and won't actually be sucked in. These stars are actually safe from the fatal attraction of the black hole. But if you do venture too close, like extremely close to the edge, then you do get sucked in.
Scientists believe there are millions of wayward black holes throughout our galaxy, the Milky Way. And because we can't readily see them, one could be right next door. So how close does something have to be to get sucked into a black hole?
Too close to a black hole is about the distance between the sun and the Earth, but that is certainly too close.
For future space travelers, death by a black hole would be a violent way to go. The method by which a black hole could kill you depends on how big the black hole is. They come in two categories. Most of them are the stellar mass black holes, which are 5 to 30 times the mass of our Sun.
If the black hole is stellar-sized, then the tidal forces near the black hole are strong enough that it will tear you apart tidally, even well outside the event horizon. If you wanted to fall into a black hole, you certainly wouldn't want to fall into one of those. It will spaghettify you.
But in addition to the stellar-sized black holes, there are others that are mammoth, millions to a billion times the mass of the Sun. And now scientists believe that these monsters hold center court in every galaxy, including our own. Black holes. They're one of the most mysterious and potentially dangerous oddities in space. A black hole has a ravenous appetite. It sucks in everything in its path and spits out what it doesn't devour. And now scientists have discovered there are supermassive black holes, which are millions of times bigger than their stellar mass cousins. And evidence suggests that supermassive black holes were born after the Big Bang, when the universe was first created.
The leading idea is that they would have formed just like a stellar black hole from the collapse of the core of a massive star. But then they grew by feeding grossly from the gas, from other galaxies which collided with them.
scientists have discovered that these black ogres wield their power in the center of galaxies.
The supermassive black holes are at the center of the galaxy, most likely because they're the most massive object within the galaxy. Massive objects tend to sink to the middle, so you'll always find them at the center of a galaxy.
For a long time, scientists didn't think a supermassive black hole existed in our neck of the universe, the Milky Way. But in 1995, astrophysicist Andrea Ghez set out to prove one exists.
We've done an experiment over the last 10 years to ask the question, is there a supermassive black hole at the center of our galaxy? And the way we did this experiment is to use the motions of stars at the center of our galaxy to test whether or not there's a large amount of mass inside a very small volume. And that's the proof of a black hole.
At the Keck Observatory in Hawaii, which houses one of the largest telescopes in the world, Ghez began using a groundbreaking technology called adaptive optics, which brings into focus faraway objects.
So this is without adaptive optics. This is what you would see. In this big square, there's nothing. We turn adaptive optics on, and you see the stars. This region contains the stars that provide the keys to our experiment. So we want to watch how these stars move.
Ghez noticed that there was a large cluster of stars orbiting around an invisible object at the center of our galaxy. And they were moving at an unusually rapid rate.
So we can actually see these stars that are really close to the center, and we can watch them go around. Those stars go around the black hole just the way the planets orbit the sun. The orbits tell us where the black hole is, so it's located right where the star is. That's the center of our galaxy. And the details of exactly how fast these stars are going around and how tight the orbits are tells us the mass of the black hole, which we think today is 4 million times the mass of our sun.
For Ghez, confirming that a supermassive black hole indeed exists at the heart of our galaxy was like summiting Mount Everest.
It was incredibly exciting to discover the supermassive black hole at the center of our galaxy, simply because it was a question we had set out to address. The question, is there a supermassive black hole? We could design an experiment that actually got at it.
Astrophysicist Andrew Hamilton says death by a supermassive black hole would be much different than by its smaller stellar mass relative.
If you want to go and be a tourist and have the ultimate experience of falling inside a black hole and finding out what's really there, go visit a supermassive black hole. Much better idea.
Unlike a stellar black hole, which would rip you to shreds before entering its deadly vortex, a space explorer could actually experience free-falling inside a supermassive black hole.
Inside a supermassive black hole, it turns out that even though the black hole is more massive, it's also much larger in size, and that means that the tidal forces are weak enough that you could pass through the event horizon and fall deep inside the black hole without being tidally torn apart. But deep down inside the black hole, the centrifugal force of the rotation of the black hole provides effectively a repulsion. If there's any matter at all inside it, then stuff that's falling in will tend to collide with stuff that's trying to get out. And the result of that collision of energies is an unimaginably chaotic maelstrom of super hot, dense plasma. And in that case, your fate is that it can roast you.
So how close would space travelers have to be to get sucked into a supermassive black hole in the center of a galaxy?
For a supermassive black hole, you would have to be about 1 million to 1 billion miles from the black hole to feel its influence.
Over the years, the Chandra X-ray Observatory has caught our galaxy's supermassive black hole nibbling on cosmic matter, not binging like other supermassive black holes.
Our black hole is today inactive compared to other black holes. Our galaxy has very little gas at the center, and so there's nothing really for the black hole to feed on.
It's not eating very much. It's going on a bit of a starvation diet.
Our galaxy's supermassive black hole appears to be fasting. This is partly due to the fact that as a galaxy ages, less and less matter is present for it to gorge on.
But in the future, it might be quite a bit more active if it ever gets a fresh supply of gas at its center to feed off of.
One way to rejuvenate our supermassive black hole's appetite is to collide with another galaxy. Sound implausible? 2 million light-years away, our closest neighbor, the Andromeda Galaxy, is charging toward us at almost 75 miles per second, or 270,000 miles per hour. In the future, scientists predict the two galaxies will collide. And upon impact, the larger galaxy may engage in one of the most primitive acts known in the universe. It's one of the most barbaric rituals in space. A larger galaxy eats a smaller one. The scenario isn't a science fiction writer's fantasy. It's a cosmic reality. It's called galactic cannibalism. The ghastly event can occur on the celestial highway when two galaxies have a head-on collision. Both eventually meld together in a less than harmonious merger.
If you're a galaxy, it's very violent. You're torn to shreds.
Joshua Barnes studies galaxy mergers. Acting like a crime scene investigator, he admits his research is a bit like inspecting a car crash.
Imagine that you come across the scene of a car crash. Two wrecked vehicles, but no witnesses. Nobody to tell you what happened. All you have is the physical evidence. That's basically what we have to do when we study colliding galaxies. So there are no witnesses to a galactic collision. All that you have is the present state of the wreckage. So you have to conduct a sort of forensic investigation to try and figure out what happened on the basis of what you have today. If they collided head-on, you would know because the fronts were squashed up, but if they, say, sideswiped each other, which is actually more likely in galactic collisions, that would leave you a completely different pattern of wreckage, and you could interpret that.
So what causes galaxy mergers?
It's gravity. Everything in the universe is falling freely through space, and where you've got two large objects like galaxies, their mutual gravity pulls them together, so they fall into each other. So it's really just the force of gravity pulling things around. The galaxies that we're seeing colliding today, most of them have been bound and destined to collide for upwards of 10, 15 billion years and they're only now just making it to that first collision.